In this, we are going to look at 7 mathematical actions that are not allowed under mathematical laws. But most of the time, students do not hesitate to do some of these. See whether you also do any of them. The first and the most common one is the cancellations. So let's see whether if you get these two, what are you going to do? So take your time and see whether you can simplify this further. So one common mistake students do is when you get an expression like that and you're gonna cancel in the first one you're gonna cancel x1 x squared with x squared. For example, you're gonna cancel x squared with x squared and write this as 3 over x minus 1. Unfortunately, this is not true. And let's look at the next one. And if you look at the next one, here again you can see square root x or square root x, and then you can see sometimes I have seen that students cancel this x, square root x with square root x and write this as 1 over 5. So unfortunately, both of these are not true, so they are not correct. So that means you cannot do that. So let's see what actually you can do. So there are two types of mathematical operations that you can do under cancellations. So, so the first one is the subtraction. So for example, if you have a and then minus a, and then you can cancel these two and get zeros. That's the first one. You cancel a minus a, so you have a, and with the subtractions you cancel them and you get 0. And the other one is the another cancellation is when you have a and a same expression a. This gonna cancel and get 1. So there are two type of cancellations. One gonna give you 0, the other one gonna give you 1. So let's look at another example. For example, let's say you have x times x minus 2 plus 2x. So that so see whether we can simplify this further. For example, if you distribute the first one, you're gonna get x squared. The second term is x times minus 2 minus 2x and plus 2x, and you can see now this is exactly what we were discussing. You can see this term and that term you can cancel because the exact same term with opposite sign, so they cancel each other and you simply end up getting x squared. So that is a valid calculation. So this is valid. And how about this one? Under division, let's say you have uh, x squared plus x divided by x squared minus 2x minus 3, something like that. Now, so what is not allowed is you cannot cancel x squared with x squared. So what we are now going to do is we're going to factor the top. So you're going to get x plus 1 from the top. From the bottom, and you can see you can factor this as x minus 3 and x plus 1, and then you can see that you can cancel x plus 1 with x plus 1. So then when you do that, what you're gonna get is from the top you can see that you're gonna get x. From the bottom you're gonna get x minus 3. So this is a valid calculation. And you cannot cancel x squared with x squared. But if you had cancelled x squared with x squared, so what you're gonna get is you get x over negative 3x negative 3, and this is not exact, does not equal to this one. So this is not correct. Okay, and then also like as another example, how about this one? So let's say you have x squared, square root x divided by square root x plus x. So again, cancelling x square root x with square is not allowed. So, but what you can do is you can factor first. So, for example, in the numerator, I'm going to leave it like that. And in the bottom, and you can see that you can write this as square root x, and x you can write as square root x times square root x. So now we can see you can pull square root x, so you can write square root x from the numerator. From the denominator you can pull square root x out, and then you're going to end up getting 1 plus square root x. So now what you can do is you can cancel the common factors. You cancel only common factors. So then you're going to end up getting, in this case, 1 over 1 plus square root x. And you can see that you do not get that if you cancel square root with square root x, then you're going to get 1 over 1 plus x, but that's not right. That's not what you get. Okay, so as a rule of thumb, what you can do is only common factors can be cancelled. Only common factors. Only common factors can be cancelled. So this is the most common mistakes students sometimes do. They just cancel the same term from the numerator and the denominator, and which is not true. You cannot cancel just a term. You can cancel only the common factors. Only the common factors. Okay, let's look at the next one. The second one is the power rule. So for example, x plus y squared. Sometimes students write this as x squared plus y squared, but this is not true. So this one is not true. And for the second one, again we have x squared plus y squared square root. So what sometimes happen is some students take the square root of the first one and the second one and write it like that. This is also not true. In the third one, x plus y square root x. Sometimes I have seen that this is written as square root x, take the square root of the first term plus square root of the second term. This is again not true. So these are all not correct. So for example, in general, x plus y to the n power not equal to x to the n plus y to the n unless n equals 1. If n equals 1, it works. But for any other values, it does not work. It's not equal to the xn plus yn. But what is true, for example, if you have x plus y squared, this is equal to x squared plus 2xy plus y squared. So you can see that there's a 2xy term coming here. So you can see that if you use the FOIL, and you can see that there's a xy term there, because there's a when you multiply x plus y with x plus y, you can see that x can multiply with y term. So that means there should be xy term. And then so what this says that if you go with the plus sign, you use the plus sign. If you use the plus sign, you will use the plus one. If you use the minus sign, you use the minus one. And the same thing works for the cube. And when you use the cube, and you can see that there are 2 extra terms coming here. And if you use again the plus sign, you have to use the plus sign for the second and fourth term. And if you use the minus sign, and you have to use the minus sign for the second and the fourth term. And now the question is, where are those numbers coming from? Actually, there's a really nice result in mathematics, what we call the Pascal triangle. The Pascal triangle is going to give you those coefficients. For example, let's look at the n equal 3 case. So it says that the coefficients are 1, 3, 3, 1. What does that mean? That means if you write x plus y cube, this is equals to x cube, because times 1, because of the first coefficient is 1, and then we're going to see plus, it says 3 times the second coefficient is 3. So this says the 3 times x squared y. So x powers goes down, y powers increases. And then the next one is, again it says 3, so it's 3. And then we have x y squared, and then finally we have plus, it says the coefficient is 1, so 1 times y cube. So it says that the coefficients are 1, 3, 3, 1, and those are 3 coefficients coming from the Pascal triangle from the third line. And if you use the second line, you're going to get x plus y squared, and we know that this is equals to x squared plus 2xy plus y squared, and the coefficients in this case 1, 2, 1. That's exactly the second line. So this is going to help you to find all those coefficients. Good. So let's look at the next one. The third one is the splitting the denominator. So for example, I have seen that sometimes students write 1 over x plus 1 as 1 over x plus 1 over y, which is not true. There is no relation like that in mathematics under mathematical laws. And the same thing with 1 over x minus 1 is not equals to 1 over x minus 1 over y. These are not true in the general mathematics. So let's look at what is allowed. So for example, when you have a expression like let's say we have x plus y divided by z. So this one you can split as x over z plus y over z. So this is allowed. So this is something that you can do, and sometimes this is really helpful in certain problems. So if you write something with numbers, for example, if you have 2 plus 7 over 3, you can write this one as 2 over 3 plus 7 over 3. So this is something valid. So you can split the numerator but not the denominator. So that's the third common mistake students do. So let's look at the next one. The fourth common mistake is not using the parenthesis. So for example, what are you going to do if you get these two questions? So what is the answer for the first one? So spend a few seconds and think of what you're going to get for the first one. For example, if you get 4 for the first one, unfortunately, which is not correct. So how the math works here is, you know that you have to do the 2 to the 2 first. So that means what's going to happen here is it's a negative, and you do 2 to the 2. 2 to the 2 means 4. So the answer is negative 4. That's what you get for this one. And for the next one, so what this says that it says that negative 2 times negative 2. So what happened? If you get 4 for the first one, what you did, you put a parenthesis which is not there, and that completely changed the problem. So for the second one, actually there is a parenthesis. So that means this means negative 2 times negative 2. So when you have two negative signs, that's a negative and negative, you know that negative negative become positive. So that means your answer is simply so it's positive, and 2 times 2 4. So you're going to get answer 4 for this one. So the second one is answer 4, first one is answer negative 4. And then so the next common mistake is sometimes students do not use a parenthesis. For example, I have seen that students write x plus 2 times x minus 1 as x plus 2. They put like a dot here and write x minus 1. The problem is this means completely different, something different. So this actual meaning of this one is, if you need to write it like this, so what happened? So you can see that this is x, and then you're going to multiply the middle terms. I mean, you're going to get 2x minus 1. So this end up getting 3x minus 1. But the problem is when you multiply the first two terms, you see that you're going to multiply x with x, and you have x squared term, and then now that x squared term is missing in the answer. So that means this completely changed the problem, and so so this is not true. So this is not equal. So do not use the dot as instead of the parenthesis. It's going to completely ruin the whole problem. So that's another major mistake students do. So let's look at the next one. The fifth common mistake is not using the order of operations. For example, in mathematics, there's an order that you need to follow to calculate certain arithmetic operations. So for example, what are you going to get for the first one? So let's say you have 12 minus 6 divided by 3. So do you get 2 or 6? Similarly, what are you going to get for the second one? 4 minus 3 squared. So you get 1 or negative 5. What about the third one? You have 3 plus 1 times 4. Do you get 16 or 7? Just think of for a second and see what you're going to get for these first. And if you get the first answers for some reason, like for example 2 and 1 and 16, they are all wrong. You do not get those answers. So the correct answer is 6 and negative 5 and 7. So let's see why this works. So let's look at what they call the order of operations, or in shortcut we normally call this a PEMDAS. P-E-M-D-A-S. P means the parenthesis, E means the exponents or the index, and then M and D, multiplication and division, they are in the same level of operations, and addition and subtraction, they are also in the same level. Now the question is, if you appear any of these, you have to follow this order from the top to the bottom. From the top to the bottom. So it's PEMDAS, P-E-M-D-A-S. MD is. Now the question is, if you see two of them at the same time, then you have to do from the left to the right. From left to the right. So let's look at these operations and see what you're going to get for these problems now. So let's look at the first one. In the first one, and you can see there's a division first, so that we have to do the division first. Because division comes first, before the subtraction. So if you do the division first, it is 12 minus, if you divide 6 times 6, if 6 divided 3 means 2. Now what's going to happen is when you subtract, now it's a subtraction, so you're going to get 10. So answer is 10. And here what's going to happen is the exponent comes first. So that means you write this one as you can say 4 minus, you do the exponents first. 3 times 3 means 3 square, which is 9. So you get negative 5. And then here you can see the multiplication comes first. So that means this should be 3 plus the multiplication. 4 times 1 is 7. 4 times 1 is 4. So that means the answer is 7. And here you can see that there's a parenthesis. You have to do the parenthesis first. So that means you write 9 minus 6 parenthesis. So when you do the parenthesis, you're going to get 2 minus 3 minus 1, which is 2. Now you can see that there's a multiplication and a subtraction. So the multiplication comes first. So that means this simply going to be 9 minus 2 times 6 times 2 means 12. So that means this is going to be a negative 3. And then the last one, now you can see we have a division and a multiplication. So if you get something in the same level, you have to do left to right. So that means you do the division first. So it is you do 12 divided by 3 first, and then you do the multiplication. So that means when you do the 12 divided by 3, that is 4, and then multiplication. So 4 times 4, which is 16. So those are the correct answers for these problems. So the next one is we're going to look at something from the differential calculus. So if you know the differential calculus, then you might understand what we're going to discuss next. So there's a so for example, when you have a product like that, sometimes what students do is they're going to take the derivative of the first one. So if you look at the first term, the derivative of that one is 6x. And then if you take the derivative of the second one, which is 4x cubed, and unfortunately if you multiply these two, you get a wrong answer. This is not true. You cannot do that. And the same thing here, when you have a quotient, sometimes what the student do is you take the derivative of the first one, which is 6x, and take the derivative of the bottom one, which is 4x cubed, and you can write it like that. And you can even simplify this one if you want. So you can see that this is 3 over 2x squared, but the problem is this is not true. So you can't use those. What you have to do is you have to use what they call the product and the quotient rule. So you cannot just take the derivative when you have a product or a quotient and write it like that, and this is going to give you completely wrong answers. So what is valid is what they call the product rule and the quotient rule. Product rule looks like this. The derivative of the product is you take the derivative of only one term and multiply by the other one. And then again you take the derivative of the u term and multiply by the other one, and there's a plus sign. So I mean the order doesn't matter, there's a plus sign. And when you have a quotient, what's going to happen is the v comes first, and then there's a negative sign, and that's what's going to happen. That's what we call the quotient rule. The next common mistake is when you have a integral and with the product, sometimes what students do is they just take the integral of the first one and the integral of the second one and write it as a product, and unfortunately which is not true. The same thing works for the quotient. If you have a quotient, you cannot just take the integral of the first one and write it like that, and just take the integral of the bottom one and write it like that, and this is also not true. In integral calculus, you have to use special relations for them. For example, for the first one, you have to just multiply through first and then take the integral term by term. So those are the 7 most common mistakes that we do in mathematics. So what is allowed is what they call the integration by parts formula. We use this one to integrate certain problems in integral calculus. Thank you.